The same thing that makes this happen makes this happen. And this. It's electricity. Whoa.
7 seconds.
Bill Nye the Science Guy.
Brought to you by Electrons, making your world a brighter place.
Hey, is your TV on? If it is, that's great. You're using electricity. But if you're watching the show and your TV's not on... Anyway, what is electricity? I mean, where does it come from? Is it just sitting in the wall waiting for us to use it? Or is it constantly spilling out of sockets and we don't notice it? And how can something so powerful be invisible? Well, electricity is the flow of tiny particles called electrons. And they're not just smaller than atoms, they're actually part of atoms. Take a look at this. It's our battery-powered electrical circuit of science. We're going to run this big light with this big battery. Watch.
Attention, Nylab.
See, right now, electrons can flow from this side of the battery, through this wire, through the switch, through this wire, into the light, and back to this side of the battery. They're flowing in a closed path, what scientists call an electrical circuit. Now, circuit, that's from an old word for go around. So electrons, right now, can go around an electrical circuit. The flow of electrons is a lot like the flow of water. No kidding. Watch. When I operate this great big water pump of science, water goes through this hose into this box and makes this water wheel go around. And it goes out the other side and through this hose back to the pump. It's a closed path for the flow of water. It's a water circuit. It's just like the flow of electrons through an electrical circuit. Electricity is a very versatile form of energy. The same electrons that are making the light up are making a motor go around. See, electricity can do all kinds of different jobs, and they're all done with electrons. Electricity is the flow of electrons. Electrons are the tiny particles that buzz around the outside of atoms. Now, when electrons are able to jump from one atom to another, well, that's the flow of electricity. Now, in some materials, like metals, electrons can jump from atom to atom very easily. Atoms in metals are like a bunch of beehives. The electrons are like the bees buzzing around the hives. When electricity flows, it's like the bees jumping from hive to hive. That's electricity.
Let's begin by looking at how a simple circuit allows a light bulb to light. A circuit is a route through which electrical current can flow. In our example, electrons flow from the negative side of a D-cell battery to a conducting material on the base of the bulb. From there, the electrons flow up a wire that is inside the bulb and across the filament, which is the part of the bulb that actually lights. When the electrons go through the filament, some of the electrical energy is changed to heat and light energy. The electrons continue down another small wire inside the bulb to another conductor on the base of the bulb. The electrons finally make their way to the positive side of the battery. There would not be a complete circuit if the electrons did not travel to the positive side of the battery, and the bulb would not light. When there is an unbroken path on which electrons flow, as in this example, it is called a complete circuit. The unbroken path that the electrons follow is called a closed circuit, because electricity will only flow on an unbroken path. The light bulb will not light unless there is a closed circuit. Let's experiment a little bit with circuits. As we discussed, electricity will only flow on a closed circuit such as the one shown on the screen. Notice that the electrons flow through the wire and each of the bulbs before they return to the battery. If one of the wires breaks, a gap occurs in the circuit and all the lights go out. When lights are lined up one after the other on a circuit like these lights are, it is called a series circuit. The problem with a series circuit is that when one light burns out and its filament breaks, it creates a gap in the circuit. All the lights go out because electricity won't be able to flow to the other bulbs. This problem can be solved with a parallel circuit. In a parallel circuit, the wires that are connected to light bulbs run parallel to each other rather than having all the bulbs in a row.
When a light goes out in this chandelier, the other bulbs don't go out. When a light in this chain of lights goes out, all the rest of the lights stay lit. And when a light goes out in this room, the rest of the lights in the room remain operable. In these examples, the lights are wired in parallel circuits. In a parallel circuit, different parts of the circuit are on separate branches. Notice how there are a lot more wires in a parallel circuit than in a series circuit. The separate branches allow the current to take several paths in the circuit. In this parallel circuit, if one bulb goes out, the other bulbs stay lit. The circuits in most buildings, including your home, are wired in parallel.
For example, if we remove the light that is closest to the battery, the other two lights don't go out because each light is connected in a way that the electrons have a complete path to travel to the positive side of the D-cell battery.